All right, here are some other problems related to similar triangles, and we're going to use a different method to find it. So here, AB is 8, and DE is 4, and AC is 16, and we're trying to find DF. So another way to approach this is to set it up as a ratio. And the way we're going to do that is we're going to say, okay, we have two fractions we're going to set equal to each other. And we're always going to put triangle 1 on top and triangle 2 on the bottom. So we're going to find sort of relationships between each. In other words, so here's x. Let's call this, let's just define, this is triangle 1, that's triangle 2. It doesn't matter which is which. So let's start here, x. So let's call x here on triangle 1. We say, what is the equivalent x on triangle 2? So the equivalent to x on triangle 2 is 16. So I write x over 16. So this is x, this is 16. They say for triangle 1, I also have 4. And what is the equivalent of 4 in triangle 2? It's 8. So what this says is x is related to 16 in the same way 4 is related to 8. That's the ultimate goal of this ratio. So 4 is connected to 8 in the same way x is connected to 16. It's a lot like the other method we used. But then what do we do to solve this? So there are a few methods. One is you could notice that from 8 to 16 it's half, so you could double them both. But a tried and true method is cross multiply and divide. So 8 times x is 8x. 16 times 4, we do that out, 64. So 8x equals 64. When you cross multiply and divide, this times this equals this times this. So this is the cross multiply. Now to the divide part, we divide each side by 8. So x equals 8. So if this side is 8 and this is 16, if this is 4, then this will be 8. In this case, that should make sense because you can tell pretty quickly we're basically just cutting in half this triangle to get this triangle. So always check and make sure your answer makes sense. So that's one problem. So now let's look at another problem. Here BC is 16, EF is 4, DE is 3, and I want to find AB. So again, let's set up our ratios. You get triangle 1, triangle 2. You have two fractions. So let's pick, it doesn't matter where you start, let's start with x. So in triangle 1 I have x. What is the x connected to in triangle 2? It's related to 3. So x over 3, they're connected. Then I want to go to triangle 1 again. I have 16. What is the equivalent of 16 on triangle 2? It's 4. So x over 3 equals 16 over 4. We can cross multiply. X times 4 is 4x. 16 times 3 is 48. So I have 4x equals 48. I divide both sides by 4, and I get x equals 12. So this is 12 if these triangles are in fact similar. And that's the approach using ratios. You can use ratios for a lot of things besides just similar triangles, but this is how we would apply it in this situation. So until next time, I am Derek Genova. Have a delightful day.